Hello everyone, welcome to DV Systems webinar series. We are excited to discuss some of our compressed air system accessories, specifically DV Systems auto drains, Ecotron condensate filtration solution, remote start kits for rotary screw air compressors, and heater kits for rotary screw air compressors. My name is Bogusz Szykovsky, Marketing Manager at DV Systems. I will be accompanied by Luke Thrush, Design Engineer at DV Systems.
Hello everyone.
A few housekeeping items before we begin. Questions will be addressed during our Q&A period at the end of our webinar, but feel free to type questions into the messages console during our presentation and we will address them accordingly. Let's begin with our agenda for this webinar. We will commence with an introduction and overview of our auto drains and why they are important to use, the Ecotron condensate filtration solution, our remote start kits for rotary screw air compressors. We will continue on with our heater kits for rotary screw air compressors and why it's necessary to use them in special case scenarios, and finally conclude with a Q&A session. So why are auto drains crucial in maintaining an efficient and properly functioning compressed air system? All atmospheric or ambient air contains moisture in the form of water vapor, which will condense into liquid water when air cools down to its dew point, the point where it can no longer hold water vapor. The amount of moisture in ambient air depends upon its temperature and relative humidity. The warmer the temperature, the more moisture ambient air can hold. Air compression generates a considerable amount of heat, and the compressed air discharged from an air compressor is relatively hot. As this hot compressed air travels through the distribution system, it cools down and moisture is condensed into liquid form, finding itself in the air receiver, air system piping, air filters, and point-of-use equipment and tools. Drain valves are crucial components of a compressed air system. An accumulation of moisture condensation in the air receiver tank will eventually limit air compressor performance, potentially result in the presence of moisture in the air lines, and cause an air receiver tank to deteriorate prematurely. Air dryers and inline filtration will also not perform if they become overloaded with liquid contamination. Also, water can back up into the air compressor and damage the machinery. Ultimately, an inconsistent supply of dry compressed air will cause production problems. For example, moisture can wash away the lubrication from air tools, causing erratic performance, downtime, and maintenance. A good example to give you a proper understanding of how much moisture condensation is generated by an air compressor is to look at relative moisture condensation levels produced by a 200 horsepower rotary screw air compressor functioning in average conditions. A 200 HP compressor operating in a climate of 60 degrees Fahrenheit with 40% relative humidity will generate approximately 50 gallons of condensate a day. However, that same compressor operating in a climate of 90 degrees Fahrenheit with 70% relative humidity will generate approximately 260 gallons of condensate a day. That's a considerable amount of condensation. An automatic drain, either pneumatic or electronic, ensures that any potential condensate is discharged from the air receiver tank regularly, optimizing system performance. Auto drains are commonly used on air compressor air receivers, blown air receivers that act as additional storage, compressed air dryers, and compressed air filter canisters within the compressed air distribution system in order to drain condensate regularly. DV Systems offers 3 types of auto drains. They all discharge condensate automatically, but do so differently. Let's begin with discussing the pneumatic auto drain. Pneumatic auto drains are primarily used with piston air compressors up to 15 horsepower and automatically discharge moisture condensate when the air compressor reaches maximum pressure and shuts down. As their name suggests, these auto drains are pneumatically operated and do not require electrical power. Their operation is triggered by either the pressure switch unloader valve, applicable on 5 horsepower to 7.5 horsepower reciprocating air compressors outfitted with a 2-stage, 2-cylinder 247 compressor pump, or the centrifugal pressure release on 10 HP to 15 HP reciprocating air compressors outfitted with the 2-stage, 4-cylinder 447 air compressor pump. The pneumatic auto drain features anodized aircraft aluminum alloy construction with a stainless steel accumulator or reservoir, stainless steel ball, piston rod, springs, strainer, retainer, and screen, along with Teflon and Viton seals. These pneumatic auto drains come standard with an XL package. A factory-installed model is available, model number AD-9400MTD. A field-installed model is also available, model number AD-9400. A repair kit is available, RK-AD-9400, and contains the internal piston, O-rings, gaskets, and screens. The pneumatic auto drain is designed to drain moisture from the air compressor air receiver each time it reaches maximum pressure and shuts down. It receives its pilot signal from the air compressor unloader, being tied into the unloader line by means of a compression T. A pilot signal, or air pressure on the unloader line, forces an internal piston past the drain port, sealing the internal chamber from atmosphere. As the piston is forced forward, the internal stainless steel ball valve is opened, permitting condensate and oil to be forced up into the reservoir. The air at the top of the reservoir is compressed to system pressure. As the pilot signal returns to zero, the internal piston returns, closing the system from the atmosphere. When the piston reaches its original position, the drain port is opened, allowing condensate to discharge. The electronic auto drain with timer is an electronic drain valve which automatically discharges condensate at predetermined intervals every X minutes for Y seconds. The discharge time and interval time can be set to suit your particular environment and application. The moisture is filtered at the strainer, ball valve, and any large particles are captured by an internal stainless steel mesh filter. The electronic auto drain features a solid-state timer with on-off indicators and a test button, and an anti-corrosion brass body. The electronic auto drain is powered by a standard 115-volt, single-phase, 3-prong plug with a 6-foot cord length. The electronic auto drain with timer requires minimal maintenance. The stainless steel internal strainer should be kept clean. Maintenance and service work must be performed while the auto drain is disconnected from power and depressurized. The electronic auto drain with timer will purge the air receiver of moisture at predetermined intervals. Once the auto drain is plugged in and operating, either of the small LED lights on or off will be illuminated. The auto drain is set to drain every X minutes for Y seconds. The internal times on the auto drain should be set according to site conditions and your experience. Remember, moisture accumulated is dependent on the temperature and humidity of your environment. Draining too often may waste air pressure by draining compressed air in addition to moisture condensate. Draining too few times may accumulate moisture condensate in the air receiver. Moisture condensate from the air receiver is filtered at the strainer ball valve. Any large particles are captured by means of an internal stainless steel mesh filter. The moisture condensate flows into the auto drain and is released based on the time intervals previously set. The electronic zero-loss auto drain is an electromagnetically operated drain valve which employs a sensor that constantly monitors condensate levels, automatically discharging accumulated condensate when full capacity is registered. The electronic zero-loss auto drain discharges condensate and not compressed air, saving you energy. The zero-loss auto drain features a test button with LED indicators. Pressing the test button will open the valve, discharging any moisture. When the LED indicator is green, the power is on. The reservoir inside the auto drain is empty, and the auto drain is waiting for moisture to accumulate. When the LED indicator is flashing green, the auto drain is discharging. When the LED indicator is red, the auto drain is in alarm mode. The zero-loss auto drain's electronic control system has a precise capacitive sensor that controls the solenoid piston valve. This special self-cleaning piston valve prevents disruption of the auto drain's operation caused by debris. The zero-loss auto drain features a compact, non-corrosive housing constructed from fire-rated plastic. The zero-loss auto drain can be maintained without any interruption to operation. The ball valve can be closed and the internal strainer cleaned quickly and easily. This should be done periodically, as needed, usually once a year. The condensate enters the auto drain from the top, A, or back, B, into the chamber, C. The sensor, D, constantly measures the level of condensate from the chamber, C. When the chamber C is full, the electromagnetic valve, E, opens and accumulated condensate is discharged. Once the chamber C empties, the valve, E, closes. The Ecotron condensate filtration system is a two-stage process that ensures that all contaminants contained in discharged condensate are effectively removed. The condensate discharged by our lubricated air compressor contains a significant quantity of oil and solid particles that will seriously pollute the environment if not removed. This mixture is classified as hazardous waste and cannot be discharged into municipal sewage systems unless the oil and contaminants are removed. The Ecotron condensate filtration system is easy to size, install, and maintain, and ensures that the filtered condensate is suitable for disposal down a municipal drain. The Ecotron condensate filtration system is a simple two-stage filtration process through two different filters. From the inlet connection, condensation is introduced into a noise pressure reduction pre-chamber 1 to allow the condensate to flow smoothly inside the separator. In this chamber, solid particles are retained by the demister path, 2, and any residual decompressed air is discharged from the top part, 3, through an odor-removing activated carbon filter. After this initial stage, the mixture of water and oil flows via gravity through the first filter, 4, which thanks to its physical characteristics, intercepts only the oil, and the water is consequently free to flow into the second stage of filtration where a deep bed of activated carbon, 5, absorbs any residual traces of oil before the water is discharged from the outlet port. A patented electronic device, 6, located next to the first filter, 4, gradually indicates the efficiency level of the first filter, allowing an easy checkup of the system. When the filter, 4, is saturated, an alarm is shown, 7, in the display, and a remote free contact advises the operator when the filters must be replaced. Now let's discuss how to simplify the daily operation of your air compressor while on site. DV Systems Remote Start-Stop Kit for Rotary Screw Air Compressors enables you to remotely start-stop an air compressor and monitor fault signals from an alternate on-site location. There are 2 variations of remote start kits, DSC-002851 and DSC-002852. The DSC-002851 remote start kit is dedicated for a 24 VAC control circuit, and the DSC-002852 remote start kit is dedicated for a 230 VAC control unit. The 24 VAC remote start kit is used with rotary screw air compressors with the following controllers: the CSC Flat 50, CSC 200, and CSC 300. The 230 VAC remote start kit is specifically used with only the Apache A5 rotary screw air compressor. For our rotary screw air compressor air system packages that include air dryers, the 24 VAC remote start-stop kit includes air dryer, remote start-stop functionality, and can be configured to turn on the air dryer in the air compressor. The remote start-stop kit includes a green power signal pilot light, a red fault signal pilot light, a lockable key switch and key for safety and security, a non-metallic NEMA 4 enclosure rated for IP65, making it water and dust tight, ideal for demanding industrial applications. Stay ahead of seasonal changes or ensure your air compressor is properly installed for special case scenarios with DV Systems Heater Kit for rotary screw air compressors. DV Systems Heater Kit is typically used in special cases where either the air compressor is located outdoors in a location where the temperature dips below 5 degrees Celsius or 41 degrees Fahrenheit at night, or returns to warmer temperatures during the day, or the air compressor is located in a cold room or space where the temperature dips below 5 degrees Celsius or 41 degrees Fahrenheit, where the temperature is unregulated. Why is a heater kit necessary in these situations? The controller on DV Systems rotary screw air compressors prevents air compressors from starting during extreme ambient conditions when the oil temperature sensor indicates that a lubricant is below 5 degrees Celsius or 41 degrees Fahrenheit. DV Systems heater kits ensures the temperature of the lubricant in the rotary screw air compressor is maintained above the temperature inhibit limit of the air compressor controller. The part number for the heater kit is DSC-002734. And this concludes our overview of some of DV Systems accessories. We will now move on to the Q&A.